Good day, folks. Welcome to my YouTube channel. Thank you for subscribing. Continue sharing and liking all my videos and watch all my videos till the end. Now, in this lesson, I'm going to look at the closed vector diagram. We know the closed vector diagram, we get it on an object that is stationary or the object that is at rest, and when an object moves at constant velocity. Now, closed vector diagram is a diagram that shows resultant force is zero, as well as the acceleration is what? Is zero, and the forces will be at equilibrium. Check my previous video. I've explained what does that mean in details. Now we have three forces acting at a point. The point is this point. This is the point. Now the three forces that are acting here at this point, there's a tension force that is going in that direction and the tension force that is going in that direction. And since this object that hangs here has a mass, so that force that is going in that direction will be the gravitational force. Right, now let's draw the free body diagram representing. So a free body diagram, you represent the point or the object that experiences the force by a dot. So we have that tension force, it's T1, and then we have that tension force, it's T2. That's T1 and T2, and we have the gravitational force there. That's the free body diagram. Now let's look at the vector diagram. The vector diagram, let me start with the gravitational force. The gravitational force is going down. We'll say it's Fg. Okay, let me write it closer here. We have the gravitational force that is going downwards, as you can see there, and we have the tension force, which is T2, is going to the right. This is T2, and then we have T1 there. Do you see? There's no resultant here. This is a closed vector diagram. It's closed. There's no resultant. There's an equilibrium. Okay, let's do another option. Another option of the vector diagram, we start with the tension force there. Okay, what I forgot there, there's a 90 there, and there's an angle theta. This theta is going to be there, and then you have another angle there, we'll call it its alpha. You have T1 there, and then you have T2 in that direction, and then you have the gravitational force downwards, right? So you have the angle theta there, and you have the angle there, and then we'll call that angle alpha. I hope that makes sense. So if you're given the two sides, let's say you are given these two, you can find this one. If you're given the two forces, this one and this one, so that means it will be this and this. You can find this using the Pythagoras theorem, right? Let's go to the second diagram. Second diagram, we have a mass that is hanging there. The mass is attached with two ropes there and one rope. So the point of interest here, it's this point there. So we have forces. We have the tension force there, which is T2 that is going, and the tension force there. So let's say this is a roof, is attached to a roof that. Now let's draw the free body diagram. We represent the point of interest there, which is this point. We have a tension force, which is T2, and we have the T1 there, and this force that is going downwards there, which is the gravitational force, because this object has a mass, so it's the mass, and the weight is pulling the object downwards due to mass. Alright, let's draw the vector diagram there. The vector diagram of that, we will start with the T1. We'll start with T1 there. This will be T1, and then we will have the gravitational force that is going down watts, which is going to be a little bit longer. That's the gravitational force. And then if you're looking at that force T2, it's going that way. T2, it's going that way. It forms a 90 there, which is there's a 90 degree there, the 90-degree force there, right? And then and that, yeah, and this will be alpha there, and this will say it's theta. Or alternatively, we'll start with T2, and the gravitational force. I'll start with T2 and the gravitational force, and we'll draw T1 there. The T1, this will be T2, and then we'll have the 90 where it's going to be the 90 will be there, right? Now let's go to the following diagram. This diagram, we have a mass there. This mass, there's a force applied to the left, and there's a tension force that is going in that direction. So there's a tension force there, and there's a force applied there, and there's a gravitational force that is acting. So three forces that are acting there. So the free body diagram of that's going to be that tension force there, and we have that force applied and the gravitational force that is going straight downwards. Now let's draw the vector diagram of it. The vector diagram there, we will start by the tension force, which is the tension force and the gravitational force, and the force applied. The force applied that way, which is going to be F, and this will be the gravitational force. So the angle that you see there, it's going to be there. Alternatively, we will have the gravitational force downwards, and then we'll have the tension force. This is Fg, and this will be the tension force and the force applied that is going to the left. The force applied that is going to the left there. So that's what we're going to do. So you'll be given two sides there, and then you find one side, or you'll be given one side with an angle, and then you find the other side there. I hope that makes sense with the closed vector diagram. So all these diagrams are closed vector diagram, but they're different way, but they'll give you same. Now let's look at this one. And this one, there's the point of interest is there in the center, right? The point of interest is there in the center. Let me use it's there in the center. If you're looking there, there are forces that are acting there. There's a force that is going, which is force 2, going in that direction, and there's a force that is going in that direction, which is F3, the force that is going in that direction. So this object basically, it's stationary, it's not moving. Even these objects that are not moving, they are stationary, they are at equilibrium. So these forces are what? At equilibrium, right? So now, drawing the free body diagram showing all the forces that are acting there, we will have that dot, and we will have force 2 there, and then downwards you have what? Force 3, and that way you have force 1 there. So drawing the vector diagram, the closed vector diagram of that, if you're looking at this force, it's due to this mass. It's the gravitational force there, it's the gravitational force there, it's the gravitational force. Based on the gravitational force, this tension force. It's based on the weight of these three objects. So the vector diagram there, I'll start with F2. F2 is going in that way. That's F2, force 2. And then you have force 3, and then you have what? Force 1 there. That's force 1. Alternatively, you can start with force 1. You can start with force 1, and then you draw force 3. This is force 1 and force 3 that is going downwards, and then you have force 2 in that way. Force 2 in that way. So you have your 90 there, and this is force what? This is force 2, right? So it's very important to understand the diagram, the forces, and draw the closed vector diagram for that.